Okay, get this. Poetry and your brain. Sounds like they're from totally different worlds, right?
Mm-hmm.
But if you're like us and love getting a deep understanding of things quickly, well, prepare for a fascinating connection.
It really is fascinating.
This deep dive is all about how science is now revealing what happens in our minds when we read and even write poetry.
It's amazing, really, to think that something we appreciate for its, artistry and emotional impact is now being looked at with the tools of neuroscience.
Yeah.
We've always felt the power of poetry, and now we're starting to uncover the biological basis for that feeling.
Exactly. We're plunging into this emerging field, neurolinguistic poetry.
Sounds a bit technical, maybe.
It might sound complex, yeah, but it's basically just the scientific investigation into how our brains process, create, and react to poetry.
Simple as that.
And we've got a fantastic report here that synthesizes research across, well, everything: neuroscience, linguistics, psychology, literary studies.
It's a great overview.
Kind of the ultimate cheat sheet for understanding how these carefully crafted words can generate such, profound meaning and pleasure.
And this report really underscores a significant shift, I think.
Yeah.
Moving from purely subjective interpretations of poetry to, well, building an understanding grounded in actual empirical evidence.
Right, like what's really going on?
It's about seeing the dynamic interplay between our brain activity, the structure of language in poetry, and our deeply personal responses to it.
And that's our mission for you today, to extract the key insights. How does poetry affect your brain and mind? We want to give you those aha moments without getting bogged down in super technical jargon.
Keep it accessible.
Yeah. So let's be super clear. Neurolinguistic poetry isn't a new style of writing poems.
No, definitely not.
It's the scientific study of what's happening in our heads when we engage with this art form.
That's a really important distinction to make early on. We're not trying to categorize poems based on brain scans or anything like that.
Right.
It's more about using neuroscience to understand the sort of universal human experience of connecting with poetry.
And the scope is huge. We're talking about how your brain decodes everything from the rhythm and rhyme to those maybe head-scratching metaphors, how creativity sparks in a poet's mind.
The creation side too, yeah.
And how we get those emotional goosebumps, the pleasure, maybe even those actual chills.
And if we zoom out a bit, look at the bigger picture.
Mm-hmm.
Studying poetry provides this incredible window into some really fundamental aspects of being human.
Like what?
Well, think about creativity itself, how we process and experience emotions, the very intricacies of language, what we even find beautiful.
Aesthetic experience.
Exactly. And maybe even, where our ability for symbolic thought came from in the first place.
Wow. It's almost like poetry is a kind of secret code that can unlock some of the mysteries of how our minds work.
That's a nice way to put it.
And it's a two-way street, isn't it? Linguistics learns about this specialized language use, and neuroscience gets this rich, complex stimulus to see how different brain parts work together.
Absolutely. Poetry engages so many different brain systems all at once: emotion, attention, reward. It makes it an invaluable tool for neuroscience to study integrated brain function in a meaningful sort of real-world context.
Okay, now before we go any further, there's a term that sounds similar but is totally different. We need to clear this up.
Ah, yes. Good point.
Neurolinguistics versus neuro-linguistic programming, or NLP.
Very easy to confuse.
Totally. So scientific neurolinguistics, that's our focus, is a well-established field. It uses rigorous scientific methods like brain imaging,
fMRI, EEG, that kind of thing.
to study the actual neural mechanisms behind how we understand, produce, and learn language.
This is the scientifically validated field we're digging into today. It's built on empirical research, peer-reviewed studies, the whole scientific process.
Right. Now, Neuro-Linguistic Programming, NLP, that came about in the 1970s. It's presented more as a set of techniques for improving communication and personal development.
You hear about it in coaching, sometimes sales.
Exactly. It talks about building rapport, using specific language patterns, stuff like that.
And while NLP uses terminology that sounds like it relates to the brain and language, it's crucial to know that it just doesn't have the same scientific backing as mainstream neuroscience and linguistics.
Okay, so less evidence behind it.
Much less. Many of its models are considered, frankly, oversimplified. And a lot of its claims just haven't been supported by strong scientific evidence when people have tried to test them rigorously.
So just to be crystal clear for everyone listening, our deep dive today is all about the scientifically sound field of neurolinguistics and its fascinating connection to poetry.
That's it.
We won't be discussing NLP at all. It's easy to see why they might be confused. The names sound so alike.
They really do.
But their scientific basis and approaches are completely different worlds.
Precisely. Our interest lies in understanding the actual brain mechanisms at play when we experience poetry, not in a set of techniques aimed at personal improvement.
Okay, good. Glad we cleared that up. So with that important distinction out of the way, let's dig into the foundational ideas that underpin this field.
Let's do it.
Our report highlights two key frameworks: cognitive poetics and neurocognitive poetics.
Right.
Think of these as like the main lenses scientists are using to explore this brain poetry link.
They're vital, really, for creating a bridge between how we traditionally analyze poetry in, say, literature studies and the scientific investigation of the mind and brain.
Okay, let's start with cognitive poetics. This is basically applying principles from cognitive science, psychology, linguistics, how we process language, to the study of literature, including poetry. It emerged, what, late 20th century?
Yeah, around then.
Yeah.
As a way to look at how readers actually engage with and experience literature rather than just focusing solely on the text itself as an object.
So more about the reader's mind.
Exactly. What's really interesting here is that shift in perspective. Instead of seeing the poem as just this fixed thing on the page, cognitive poetics examines the dynamic interaction between the poem and your mind. The mental process is happening as you read.
And it uses some really insightful core concepts. Take schemas and mental models.
Okay.
This is about how you, as a reader, use your existing knowledge, your understanding of concepts, events, situations,
Your background knowledge.
to make sense of a poem and build a mental picture of what's going on. Think of it like when a poem mentions a dark forest, your brain instantly pulls up your forest schema, right? Trees, shadows, maybe a feeling.
Yeah, a sense of mystery, perhaps. Or if it mentions a storm, your brain doesn't just process the word storm. It activates a whole network of associations: wind, rain, thunder, maybe even feelings of fear or, comfort, depending on your experiences.
Right, based on your past. Okay. Then there's foregrounding and defamiliarization.
Key concepts.
This is about how poets often use unusual language, maybe surprising word order, striking metaphors, unexpected sounds,
Things that jump out at you.
to make certain parts of the poem stand out. This disrupts our normal, automatic way of processing language, creates a sense of novelty, which can lead to deeper engagement.
It makes you pay attention.
Exactly. By using unexpected language, poets are essentially forcing our brains out of autopilot, makes us pay closer attention, creates a more impactful experience. That seems like a key insight into how poetry grabs us.
It's like the poem is giving your brain a little jolt, making you notice something you might otherwise just gloss over. And this defamiliarization can actually change how you perceive what's being described.
Another key idea: embodied cognition. This suggests that our understanding, even of abstract stuff in poetry, is rooted in our physical bodily experiences, our sensory motor processes.
How we interact with the world physically.
Yeah. Words can actually trigger memories of physical sensations and the feelings that go with them. So when a poem talks about a heavy heart,
It's not just a figure of speech.
well, the idea is it's more than just a figure of speech. Your brain might actually activate neural pathways related to the physical sensation of heaviness, connecting that abstract emotion to a concrete embodied experience.
Exactly. Our understanding isn't just intellectual. It's deeply connected to how we experience the world through our bodies.
Then we have theory of mind, or mentalizing.
Right. Understanding others' minds.
This is especially relevant for narrative poems, ones with characters. It's our ability to attribute mental states, beliefs, desires, intentions, emotions to these fictional characters.
So we can understand why they do things.
Yeah, allows us to understand their actions, feel empathy. This is what lets us get invested in the stories poems tell, to care about the characters, understand their motivations, even if they're totally different from us.
It's how we connect with characters and their experiences, even if they only exist in the poem's world.
Of course, figurative language, huge part of poetry. Cognitive poetics looks closely at how we process metaphors, similes, all that non-literal stuff.
And we make sense of it.
Yeah. It explores how these figures contribute to meaning, create vivid imagery, and have an aesthetic impact. Metaphors, for instance, they're not just decorative, are they?
No, they're fundamental to how we think, often.
They help us understand something abstract by relating it to something more concrete, creating new connections in our minds, offering fresh perspectives.
They provide alternative ways of understanding, yeah. And they can evoke powerful imagery and emotions just through that comparison.
And affect and emotion are also central here. Cognitive poetics recognizes reading poetry isn't just a thinking exercise. It's deeply tied to our feelings.
Absolutely.
It looks at how different elements, the words, the sounds, the themes, can evoke specific emotions and moods in the reader. This moves us beyond just analyzing structure
To understanding its emotional power.
and how it resonates with our own feelings and experiences.
It acknowledges that our emotional response is a key part of the whole poetic experience.
And finally, there's this concept of resonance.
Resonance.
This tries to capture that lingering feeling or sense of significance that some really powerful poems leave with us long after we've finished reading.
That lasting impact.
Yeah, it's a bit more metaphorical itself, encompassing the subjective psychological impact. It's that feeling that a poem has somehow changed you, or it keeps echoing in your mind, bringing new insights or emotional depth over time.
It's the poem's enduring effect on our thoughts and feelings, a kind of cognitive echo.
Now, cognitive poetics is closely linked to cognitive linguistics, right?
Very closely. It borrows a lot of its theoretical tools from there.
Like conceptual metaphor theory, the idea that we understand abstract concepts through metaphors based on concrete experiences.
Like argument is war, or love is a journey.
Right. And blending theory, how we combine different mental concepts to create new meanings. Cognitive poetics uses these to analyze how these cognitive mechanisms create those aesthetic and emotional effects specifically in poetry.
Exactly. So while cognitive linguistics might look at metaphors in everyday language, cognitive poetics focuses on how poets specifically wield them to achieve particular artistic goals, focusing on that aesthetic and emotional punch.
Got it. So it applies the linguistic insights to the unique context of poetry.
Precisely. It uses the findings of linguistics to really unpack the unique power and characteristics of literary language and form.
We should probably mention some key figures who shaped cognitive poetics, people like Reuven Sir, Peter Stockwell, Mark Turner, Gilles Ficonia.
Lakoff and Johnson, of course, with metaphor. Margaret Freeman, too.
Yeah. These individuals really laid the groundwork for understanding the cognitive processes involved in reading and experiencing poetry. They provided the theoretical framework that neurocognitive poetics would later build on.
They were definitely pioneers in bringing that cognitive perspective to literary study.
Which brings us nicely to neurocognitive poetics.
Oh, the next layer.
This is a more recent field. It takes everything from cognitive poetics, but adds the methods and findings of neuroscience. So they're using tools like fMRI,
which shows brain activity where things are happening,
and EEG,
which measures electrical activity, the timing of things.
We actually look at what's happening in the brain while people are reading poetry.
Or listening to it off of the scanner.
Right. The goal here is to find biological evidence for those literary effects that cognitive poetics describes.
To ground the theories in brain data.
So instead of just theorizing about how, say, foregrounding might affect us, neurocognitive poetics tries to see which brain parts are more active when we encounter those unusual linguistic features. It's about finding the neural correlates of our literary experiences.
It's about grounding those claims of cognitive poetics in actual measurable brain activity.
And a central framework in this field is the Neurocognitive Poetics model, or NCPM.
The NCPM, yeah, important model.
One of its key ideas is dual route processing. It suggests we process literary texts through two main pathways.
Two ways the brain handles it.
There's a fast, automatic route for familiar language and basic comprehension, the background of the text.
Kind of like cruising altitude for reading.
Yeah. This route is thought to be linked to our responses to the narrative, the story in a poem. Helps us follow the plot, understand the basic situation. It's efficient, not much conscious effort needed.
It's our brain's way of quickly making sense of the basic information flow.
But then there's a slower, more controlled route. This gets activated by those foregrounded elements, the stylistic things that stand out.
And the bumps in the road, the interesting bits.
Right. This route triggers that defamiliarization we talked about, and is thought to be really important for aesthetic processing and those artifact emotions, our feelings about the poem as a work of art itself.
Not just the story, but how it's told.
These are the elements that make us stop and think, that disrupt our automatic processing and make us consciously reflect on the language and its effects. It's where we might experience that aha moment or appreciate the artistry.
The interplay between these two roads is what creates the rich experience of reading poetry, according to the model.
So poetry works on us in two ways. It tells a story we follow, but it also throws in these linguistic curveballs that make our brains work harder.
Engage more deeply.
And ultimately lead to that artistic appreciation. So the NCPM distinguishes between the background context, immersion, and the foreground grabs attention, deeper engagement.
And it's through this interplay, this contrast, that the overall experience emerges. The foregrounded bits stand out against the background.
It enhances our awareness of the language itself.
Exactly.
The model also includes some interesting hypotheses. There's the fiction feeling hypothesis, suggesting emotional narratives engage our empathy networks, leading to immersion.
Makes sense. We feel with the characters.
And the Panksepp-Jacobson hypothesis, which proposes a link between the emotional qualities of poetic language and some very ancient fundamental emotion systems in our brains.
Connecting poetry to basic, evolved affect system.
These hypotheses try to connect our literary experiences to broader psychological, even evolutionary principles, suggesting our responses might be rooted in very basic biology.
They attempt to ground these literary experiences in our fundamental neurobiological makeup.
And a key prediction of the NCPM is that our overall response, whether we like a poem, find it beautiful, comes from complex interactions happening at all different levels of language.
Not just one thing.
No, from the sounds of words, their meanings, how they relate in sentences, the broader themes, it's multi-layered. Everything contributes to the final aesthetic and emotional impact.
It's a holistic view, how all these linguistic levels interact to create the poetic experience.
Some key figures in neurocognitive poetics. Names like Arthur Jacobs, Rainer Schrott, Stefan Kolsch, Winfried Menninghaus, Raymond Marr.
Right, these are researchers actively using neuroscience tools to test the theories, providing empirical data.
They're at the forefront of using brain science to understand how we engage with literature. So, to sum up the relationship, cognitive poetics comes first, identifies processes, forms hypotheses. Neurocognitive poetics uses brain measurements to empirically test those hypotheses.
It's hierarchical. Neuroscience validates and refines the cognitive models.
But, as you hinted, there's a trade-off. Brain data is rich, but the lab environment.
Yeah, lying in a noisy scanner isn't quite like curling up with a book, is it?
Exactly. It can limit how natural the reading experience is.
You gain detailed brain info, but might lose some real-world nuance. It's a constant balancing act between scientific rigor and the richness of human experience.
It's a fascinating area where science is really trying to illuminate the art of poetry. Our report even includes a table summarizing the key differences between the two fields: focus, methods, concepts, figures, limitations.
Oh yeah, that table's useful.
It really highlights how they complement each other. Cognitive poetics asks the questions, neurocognitive poetics tries to answer them with data.
Provides a clear overview of these distinct yet complementary approaches.
All right, so now we have the frameworks. Let's dive into what's actually happening in your brain when you encounter poetry. The neural correlates of reception. This stuff is pretty mind-blowing.
It truly is. Reading poetry isn't just decoding words. It's this rich interplay of different brain systems, sensory, cognitive, emotional, aesthetic, all firing together.
Let's start with the form: rhythm, rhyme, meter. Not just pretty sounds, right?
Definitely not. They actually engage specific neural processes. While research on poetic meter itself is still developing, we can learn a lot from studies on music and language processing.
Our brains like rhythm.
We're incredibly sensitive to rhythmic patterns, and the predictability of something like meter might actually help our brains process the language more fluently.
Easier to follow.
Could be. There's a theory these regular structures might even activate the brain's reward system.
Ah, so it feels good.
Potentially, yeah. Contributing to the pleasure we get from verse, maybe helping integrate the information. It's like our brains appreciate the pattern, the predictability.
And this ties into research showing how rhythm influences language comprehension, too.
Exactly. So the temporal structure of poetry is likely interacting with some very fundamental timing mechanisms in our brains. The musicality is deeply connected to how our brains handle sound and pattern.
Okay, moving on to meaning. Semantics, figurative language. Poetry often packs a lot in, uses non-literal language. How does the brain handle that?
Well, neurocognitive research is exploring this using techniques like ERP's event-related potentials.
The timing ones.
Yeah, they track the brain's responses in real time. You can see how the brain reacts to semantic processing, like when something doesn't make literal sense, or when interpreting a metaphor.
So you can see the brain detecting an anomaly.
Precisely. ERPs show different stages. Detecting the anomaly, then the effort to make sense of it, like with metaphors or irony. They give a millisecond by millisecond view.
And this connects with neurolinguistic approaches using ideas like conceptual metaphor theory.
Right. Understanding abstract ideas through concrete ones, love is a journey. They look at how we map the concrete idea onto the abstract one. Understanding that metaphor involves your brain activating networks related to both love and physical travel, creating this new blended understanding.
So metaphors create novel connections, help us grasp abstract things tangibly.
Exactly.
Our report also emphasizes how individual words themselves have power. Emotional valence, positive or negative.
Arousal level, exciting or calming.
Imageability, how easily they create a picture. Even how pleasant a word sounds.
Sonority, yeah. All these influence neural processing and our subjective responses. Words aren't neutral. They come loaded with associations.
Researchers are even trying to quantify the aesthetic potential of words based on this stuff.
And it's fascinating how much weight a single word can carry. Think of Bueller's spheric fragrance of words they carry associated feelings or one-word poetry.
Shows the power at the most basic language level.
It speaks to the idea that language is deeply connected to our sensory experiences and emotions, even down to the individual word. Each word has a unique emotional and sensory signature.
Okay, let's talk emotional punch. Poetry evokes strong feelings. Neurocognitive studies confirm this.
Oh, absolutely. They show listening to poetry can trigger emotional responses as intense as music.
And these aren't just subjective feelings.
No, they're measurable. Skin conductance changes, heart rate shifts, even tiny changes in facial muscles detected by EMG.
Objective evidence of the emotional impact.
Our physiological responses reflect that deep emotional connection we can have.
And even more interestingly, they've pinpointed brain circuits involved. Peak aesthetic experiences like getting chills.
Yeah, those shivers down the spine.
They seem to light up the brain's reward circuitry, especially the nucleus accumbens.
Similar to music we love, though maybe with some specific differences for poetry.
So our brains are actually rewarding us for engaging with poetry. Maybe for the language play, the emotional resonance.
It seems our brains find pleasure and reward in the intricate patterns and emotional depth of poetry.
But here's where it gets really interesting. You mentioned this paradox.
Yes. Sometimes those moments of peak aesthetic pleasure coincide with physiological markers, usually associated with negative emotions.
So you feel intense pleasure, but your body shows signs of, like, negative arousal.
Exactly. It challenges the simple idea that aesthetic pleasure is just feeling happy. It suggests a difference between our emotional response to the content, maybe sadness or fear, and our aesthetic appreciation of how it's presented.
Which ties back to the NCPM's distinction. Narrative emotions versus artifact emotions.
Precisely. How we feel about the story versus how we feel about the poem is art. Our brains seem able to derive pleasure from skillful construction, even when the subject is sad or difficult.
We can appreciate the beauty in tragedy, the power of expressing sorrow well. It's a more complex emotional landscape.
We can appreciate the artistry even when the content evokes negative feelings.
And what about judging a text as literary or beautiful? Are there neural correlates for that?
Neuroscientists are starting to explore that. Some studies compare responses to poetry versus plain prose, looking for neural signatures of what we perceive as literary.
Oh, what do they find?
Well, it seems aesthetic appreciation might be linked to successfully processing those foregrounded elements we talked about.
The stylistic stuff that stands out.
Yeah. The idea is when we recognize and appreciate the poet's artistic choices, those deviations from ordinary language, it triggers a specific neural response that we interpret as aesthetic pleasure. Our brains seem attuned to recognize and reward artistic skill in language.
There's even research trying to predict word beauty just from linguistic features.
Which further supports the idea that aesthetic responses are partly rooted in the formal properties of the language itself. Like, there's a kind of beauty code our brains are attuned to.
Certain linguistic features seem to consistently elicit aesthetic appreciation.
It appears so.
Finally, let's touch on immersion, resonance, that feeling of being lost in a poem.
That transported feeling.
The NCPM simulation hypothesis suggests that reading evocative texts engages brain parts involved in imagination, memory, perspective taking.
Right.
This mental simulation could be what creates that immersed feeling. Like our brains build a virtual reality from the language, letting us experience the events and emotions.
A kind of neural enactment.
And that resonance, the lingering impact, might be connected to these immersive processes, how the poem captures and releases our attention, how it builds those mental worlds.
The feeling of being transported likely involves these imaginative and perspective-taking processes in the brain.
So overall, reading poetry, it's this incredibly active, integrative process. Language centers, emotion networks, cognitive control, attention, memory, sensory simulation, a whole symphony of neural activity.
It really paints a picture of the brain actively engaging with language on so many levels when we read poetry. It highlights the remarkable capacity of our brains to appreciate this complex art form.
Okay, so we've looked at the reader's brain. What about the other side? The poet's brain during creation. Our report delves into this, and studying creativity like this, it sounds tricky.
It is. How do you capture something so internal as writing poetry with scientific tools? It's a real challenge.
Well, researchers are getting creative. One approach: have poets compose short poems in an fMRI scanner.
While lying down and trying to be creative?
It,
Wow.
it lets them look at brain activity during different stages, maybe idea generation versus refining, and then relate that activity to the poem's quality judged by experts later.
Linking brain activity to creative output.
They even look at related things like lyrical improvisation. This simultaneous look at process, product, and skill level is really innovative.
It's a fascinating way to try and get a window into the creative mind at work.
And creative writing, it seems, often involves two distinct phases: initial generation of ideas, then revision and refinement.
Makes sense. Getting it down, then polishing it up.
Neuroimaging studies show these phases have different neural signatures during poetry composition.
The brain likely engages different resources for those two tasks.
Exactly. During the generation phase, coming up with new material, there's often increased activity in the medial prefrontal cortex, the MPFC.
Which is involved in?
Motivation, self-generation, initiating things. But interestingly, at the same time, there's often decreased activity in areas for executive control, the brain's editor.
Like the DLPFC and IPS.
Right, the dorsolateral prefrontal cortex and intraparietal sulcus. This suggests that in that initial creative flow, it might actually help to have less top-down control.
Let the ideas flow more freely.
Yeah, allowing for more free association, less constrained thinking, driven by that MPFC motivation. It seems like the brain temporarily loosens its grip to allow more novel connections.
They also see more activity in language areas, obviously, but also memory, emotion, imagery areas. So it's letting go of control while tapping into various resources.
Like opening up to a wider range of possibilities, drawing on different info and associations, a state of focused exploration but reduced inhibition.
Okay, what about revision?
When the poet moves into revision, the pattern shifts. Typically a significant increase in activity in the DLPFC and IPS.
The editors are back online.
Exactly. Re-engagement of higher-level cognitive control, self-monitoring, evaluation, planning, working memory, all needed to critically assess and modify the writing. The analytical part kicks in.
The brain shifts from generating to evaluating and refining.
And expertise, as you might guess, plays a big role. Studies comparing expert poets with novices show differences in brain activity and connectivity, especially related to poem quality.
Experience shapes the creative brain.
It seems so. For example, when expert poets produce technically skilled work, they show stronger connections between the MPFC motivation and language regions during generation.
Better integration. Translating intention into skilled language more efficiently.
That's the idea. More efficiently wired to translate creative drive into skillful language.
Okay, what about innovation? Not just skill, but real creativity.
Ah, that's different. When experts produce highly creative poetry, they tend to show weaker connections between the DLPFC control and sensoromotor areas,
Less top-down control again.
but stronger connections between emotional processing regions like the orbitofrontal cortex and those sensoromotor areas.
Interesting. So maybe innovation needs less strict control, allowing unconventional combinations, possibly driven more by emotional input.
That's the suggestion. Becoming an expert isn't just mastering technique, it's learning when to let go of control to innovate. It's a fascinating insight into the neuroscience of creativity itself.
It highlights that delicate balance between control and freedom, especially for experts.
So expertise in poetry seems to involve this flexible control over cognitive resources, knowing when to loosen the reins for novelty, when to tighten for refinement, and enhanced integration across systems.
Experience leads to a more nuanced, flexible deployment of cognitive resources for poetic creation.
Our report also has a helpful table summarizing key brain regions in poetry creation: MPFC, DLPFC, IPS, language areas, sensoromotor, limbic memory. orbitofrontal cortex, their roles in generation revision, and how expertise affects them.
A useful snapshot of the neural choreography involved in bringing a poem to life.
All right, so we've explored the reader's brain, the poet's brain. Let's zoom in now on the linguistic dimensions. How does the language itself contribute? Our report emphasizes poetry's impact is rooted in its skillful manipulation of language at all levels.
It's language at its most deliberate, most artful. The careful crafting is central.
Absolutely. Let's start small. Words themselves. Research shows individual words have inherent affective aesthetic qualities.
We touched on this valence, arousal, imageability, sonority.
Right. They all contribute. Words aren't neutral. They carry emotional weight, sensory associations. There's even research trying to predict word beauty based on these features.
Supports the idea that aesthetics start right at the word level.
It echoes those older ideas like spheric fragrance or one-word poetry. Even a single word can have poetic function. Embodied cognition theories suggest even abstract words activate networks connected to real experiences.
Like each word has its own emotional and sensory fingerprint, contributing to the poem's texture. The inherent qualities form the foundation.
Then we have rhetoric, semantics, poetic devices, metaphor, metonymy, irony.
Figurative stuff.
Cognitive poetics and neurolinguistics are really interested in how our brains process these non-literal uses, the complex conceptual mappings involved. They aren't just flourishes, they actively shape understanding and experience.
They create layers of meaning, evoke vivid imagery.
Researchers use ERPs to track the real-time brain response, the cognitive effort in interpreting them. This draws from cognitive linguistics, conceptual metaphor theory, or blending theory.
Using those theories to understand the cognitive mechanisms making figurative language so powerful. Insights into how our minds create and interpret non-literal language poetically.
Here's an interesting angle. Linguistic relativity. The idea language influences thought.
The Sapir-Whorf idea.
Yeah. One researcher, Guillaume Thierry, suggests poetry, with its condensed, unconventional language, might have a unique power to shift perception. Create a before and after state in understanding.
Because it's so concentrated and evocative.
That's the idea. A more immediate, intense shift in conceptualization compared to other language, like a linguistic shock, jolting us into seeing differently.
Poetry's unique language use might indeed have a more direct, potent effect on perception. Interesting thought.
And finally, syntax, structure, the overall text worlds a poem creates. Line breaks, stanzas, narrative organization. They all contribute.
The architecture of the poem.
Theories like text world theory look at how we build mental representations of the poem's world, how linguistic cues guide us through different perspectives. The structure, rhythm, theme development, they guide our cognitive and emotional journey.
The formal elements play a crucial role in shaping our experience and understanding.
So putting it all together, poetry's power really lies in this deliberate, skillful use of language at every level: word, phrase, structure. It engages cognition, evokes emotion, maybe even subtly reshapes perception.
It's a testament to the power and versatility of language used with such artistry. Poetry demonstrates language's remarkable potential to move, inspire, and change our perspectives.
Now, to actually investigate all this, researchers use a really diverse set of tools. Our report outlines key methods in neurolinguistic poetry research. It's truly interdisciplinary.
Needs expertise from neuroscience, psychology, linguistics, computer science. A wide array is needed to tackle the complexity.
Let's start with brain imaging. We mentioned fMRI, great spatial resolution, shows where things happen.
And EEGER's fantastic temporal resolution shows when things happen, tracking those millisecond responses to linguistic features.
So fMRI for where, EEGER's for when, crucial insights into the neural activity. They also use psychophysiological measures capturing bodily responses to emotion and aesthetics.
Like skin conductance.
Electrodermal activity, yeah. Heart rate, facial EMG measuring muscle activity. They tell us about emotional state, response intensity.
An objective window into those often subconscious emotional and physiological changes when we engage with poetry, quantifying the impact.
And of course, behavioral methods are still crucial. Rating scales for subjective judgments.
Reaction time tasks for cognitive load.
Think aloud protocols for qualitative insights. Analyzing poems written in composition tasks.
These help understand the conscious experience, complementing the brain and body measures. Valuable info on perceptions and cognitive processes.
Finally, quantitative narrative analysis and computational stylistics, using computers to analyze linguistic features systematically.
Word frequency, syntax, phonology, using effective norm databases to quantify word emotion.
These computational methods find patterns in language linked to specific neural or behavioral responses, helping generate testable hypotheses. Powerful tools for analyzing intricate structures. And the report emphasizes combining methods gives the richest insights. An fMRI study might also collect psychophysiological data and ratings.
Multimodal approach.
Yeah.
Gives a more complete picture.
It's about triangulating findings from different levels, brain, body, subjective experience for a comprehensive understanding.
Integrating different methodologies allows for a more holistic and robust understanding.
It really highlights how this field needs expertise across many areas and the ability to bring findings together meaningfully. Collaboration is key.
The interdisciplinary nature is one of its greatest strengths.
So this field is clearly making exciting strides, but like any emerging area, it faces challenges, critiques, and there are lots of open questions. Our report covers these too.
Important to acknowledge limitations and debates. A critical perspective is essential for growth.
One major challenge: ecological validity. Can we generalize lab finding someone in a scanner to natural reading?
It's tough. Studies often use short excerpts, recited poetry, not the same as reading a book at home.
There's always that tension, experimental control versus real-world engagement. Bridging that gap is ongoing. Another challenge: poetry's complexity. It's this web of language, form, culture, individual experience. Isolating one variable's impact is hard.
And the NCPM suggests nonlinear interactions between levels, complicating it further. Poetry is complex, our responses are complex, hard to disentangle contributors.
The multi-layered nature presents significant analytical hurdles. There are also theoretical debates within the field.
Like the scope of cognitive poetics.
Yeah, internal discussions about its focus, relation to literary studies, linguistics, and the NCPM, while valuable, is still developing, early hypotheses being revised. Needs better integration of individual differences, cultural context.
It's a healthy sign of a developing field. These internal discussions, refining models, ongoing theoretical refinement is natural.
And a broader concern: reductionism. Risk of explaining rich experiences only via brain activity, overlooking meaning, context, interpretation.
Need to keep dialogue between science and humanities going.
Right. We need to be careful not to reduce the poetic experience just to neural activations, meaning personal connection are crucial too. Maintaining that balance is vital. One fundamental gap researchers are still trying to bridge: the language-emotion gap.
How do words make us feel things?
Exactly. How do abstract symbols translate into visceral feelings, physiological responses? We don't fully know the precise mechanisms.
Closing this gap needs insights from effective neuroscience, linguistics, cognitive theories of emotion. Unraveling that neural link is a central goal.
But lots of exciting future directions. Studying how poetry appreciation develops in kids.
Developmental neurocognitive poetics, still largely unexplored.
Systematically looking at individual differences, personality, experience, culture, how they affect responses.
Understanding these factors gives a more nuanced picture. Future research will likely focus on them.
We'll likely see advancements in computational modeling, AI analyzing subtle features, predicting responses.
And more studies integrating creation and reception, understanding that relationship.
Exploring the interplay between the poet's and reader's brain could reveal fascinating connections.
Future studies will likely explore that, using advanced computational tools.
And it's crucial to expand beyond Western languages and cultures. Are responses universal or culturally specific?
And more focused studies on specific devices, metaphors, meter variations.
Cross-cultural research helps understand how background shapes response. Focusing on devices gives targeted insights into neural computations. Expanding the scope is crucial for a more universal understanding.
Yeah.
Ultimately, the big goal is to move beyond broad correlations.
Brain activity and reading poetry.
To pinpoint specific neural computations triggered by precise linguistic and structural features poets use. And crucially, understand how those computations lead to subjective aesthetic and emotional experiences. Finally, tackling that language-emotion gap.
Moving from broad mappings to understanding the fine-grained neural mechanisms. The future lies in identifying those specific neural processes mediating our complex responses.
So, to recap our deep dive, what have we learned?
Well, neuro-linguistic poetry reveals incredibly complex brain activity when we read and create poetry.
Not just language emotions, reward, cognitive control, all working together?
We've seen how expertise involves flexible use of brain networks, knowing when to control, when to let go for creativity.
And we've highlighted how deeply poetry's impact is rooted in its linguistic structure at every single level, from word sounds to overall form.
Poetry serves as this powerful example of how our brains integrate diverse cognitive functions to create rich, meaningful experience.
And the implications go beyond poetry. Insights into human creativity, aesthetic experience, the power of language to shape thought and emotion.
Potentially connecting to embodied experience, fundamental cognitive abilities.
Studying poetry offers a unique window into the very essence of human cognition and experience.
So for our final thought for you, consider your own experiences with poetry. How might these intricate processes we've discussed be reflected in how you respond?
Maybe pay closer attention next time. How specific words or sounds evoke feelings or images for you? It's a chance for your own personal exploration at this fascinating intersection of science and the humanities.
The dialogue is ongoing, and your own experience is definitely part of that conversation.